So, Steve Shrader with Euclid Timber Frame with one hat. Euclid Timber Frame, 20 years ago, I was wearing Carhartts and had a beard and was out in the field doing what I thought was mass timber construction. And we were building timber frames in the Park City area, Jackson Hole, and even in parts of Colorado. This is our shop in Utah. It's a location in Heber, Utah, where we have a timber frame shop and our Hundegger shop. It's a really interesting tie to Europe. The three of us up here have kind of been influenced a lot by wood and wood in Europe. Euclid Timber Frame, gosh, we were just it was started off as a small family business, and then it's kind of grown. We've got about 45 employees now. And in about the late 1990s, we were doing everything by hand. We had about 5 customers. We were telling them we were 2 years out. And they said, we don't care. We want a timber frame. We love them. And it was the late to mid-90s. One of the principals of the company went over to Germany and had heard about this CNC machine called Hundegger. And he came back and said, we bought it. And it put us in a little bit of a bind. Some of us were freaking out a little bit. And basically what we did is we went to those 4 customers and said, if you prepay, we will get this project to you this year, and we'll discount it for you if you trust it. So they did it. We paid for the machine, and we did 2 other projects that year with our Hundegger. Real quick, funny story with Euclid. The name came up because of some books we were reading on timber framing, figuring out exactly where we were going to go, and some of you in this room may understand when this was really coming on strong. But Euclid was a Greek mathematician, and he kind of was the precursor to Pythagoras. How many of you know what the Pythagorean Theorem is? A squared plus b squared equals c squared, right? So this was probably one of the biggest nemesis of my junior high geometry problems when I was growing up. And my answer to algebra or Pythagorean theorem was if you could find the x, that I just circled the x, that there it is, teacher, and went forward there. But Euclid took it a little bit further, and one of the themes that I have named this actual presentation has a lot to do with Euclid, and I didn't really know it. And it has a lot to do with our industry and kind of the 3 of us up here on our presentation. The book that he wrote, Book of Elements that he wrote, was actually used up until like the 40s and 50s. But the very first book had these 5 common notions, and the bottom one there is kind of what the theme is for me, that the whole is greater than the part. And I hope that as we go through this, you'll understand where I'm going with that theme. What happened was geometry started to really catch on in Europe at this time after Euclid and Pythagorean. They started because of building, literally because of construction. They could then figure out angles and 90 degree, and they could do more design work, and architects kind of started getting into this whole engineering building thing. They were all 3 one at the time. And there's a little town south of Frankfurt called Miltenberg, and some of the most fascinating timber structures that are 900 years old. This village is absolutely pristine, and I strongly recommend, if you ever get over to Germany, to go south of Frankfurt to a little town called Miltenberg. This is a hotel that I've stayed in, actually, and it literally is 920 years old. And 80% of it's timber, mass timber, heavy timber. I wanted to now kind of shift a little bit into what that means to us in Hundegger, and hopefully you can stick with my random thoughts here. But this is what timber framing became, what mass heavy timber became in Europe, and it was somewhat crude. And over the last 300, 400 years. And these structures are still standing. This is actually a shot of a barn roof close to the town of where the Hundegger saws are actually built. Today, this is the type of truss system and rafter systems and mass timber roof systems that companies like Hundegger and Laurent, when he talks about his business and stuff that StructureCraft has been doing, and how we've evolved to this. This is actually a picture of our first machine, Hundegger, and we purchased this machine, and then we purchased another, and then we purchased another, and in that whole time, Hundegger asked us to rep these machines in North America. And a lot of companies have grown and expanded because of these machines. This is actually the 5-axis mill, one of the biggest innovations when Hundegger first came out, but currently the company has installed 4,700 machines worldwide. Most of the productive and innovative contractors throughout Europe and here in the U.S. with timbers are implementing this type of technology in their workshops, and they are employing very highly skilled and highly educated people inside their workshops. So the transition from paper or idea to computer is a very interesting one. I'm going to kind of go through this quickly because Laurent is going to talk a little bit about that. But this is, we design everything within one of these FIM or BIM type of programs. When CAD first came out here in the U.S., it was heavily influenced for design. Over in Europe, immediately thought, how can we take this into production? And like Lucas was talking about with his 3D model of a building, what these programs actually do is they break each part into a 3D dimensional parametric type of a individual piece so that the machine could then recognize that. And we can sequence, just like he was sequencing the actual panels, we can sequence every part of that panel or every beam, every column in that structure so that it's going through the machine before it goes on the truck so that Lucas can deliver it as he stated. And everything is also able to be simulated. I think there was a presentation earlier that was showing how they were simulating in a CAD program exactly what the machine, this is actually our machine software showing the different milling units, cutting, milling, and doing the different joinery with a sample of the actual picture of the beams that were being cut is right there, what was being simulated. So this is one of our projects in Utah. We can cut one of these buildings faster than it takes to lay it out. With a pencil, a tape measure, and a framing square, and speed squares, I mean, it takes a lot of time to lay out every part. But the tolerances, and when we're talking about manufacturing and fabrication, it's not like you can just buy a panel and stick it and nail it up against some beams or some columns. I mean, there's a lot of details in the joints and the corners and how this thing goes together. And designers, engineers, like Lucas was talking about, software people like Laurent, you need to make sure that this is all integrated into the system, that there's some thought into it. And the software and these machines, you have to understand what your limitations are with the machines, what you can do, what you can't do. And the whole system, the whole thing together is greater than the part, if that makes sense, in my theme. This is a picture of what types of things can be done now and how complex things can get, but yet how simple they can be with the right technology. The reduce of shop space, the reduce of waste on site, it's much safer than doing everything on site. Much more efficient, and you can actually pay attention to details for energy loss, energy code, and as you're building it and designing it. And this is actually a rendering of a house that was that came to reality, and it can be done to where you don't even have to fit something in a shop. It'll come right off the machine, go to the site, and it can be installed exactly as it was designed. So about 4 years after our relationship with Hundegger, and moving forward. We moved into the log home industry. We provided a machine that the SIPS industry was very closely related to. The structural insulated panel industry was very closely related to the timber frame industry, and they were shelling our timber frames with these SIPs. And a lot of the buyers, customers here in the U.S. went to Germany and said, Hans, everyone in Germany is named Hans. Hans, we need a machine that can cut panels, particularly SIPs, jumbo panels, 9 feet by 20 foot. And so Hans went to work and he started building this. Well, it was very interesting because about that same time, CLT started becoming popular in Germany. And a lot of people were saying, Hans, how did you know? How did you know to build a machine that could cut a large jumbo CLT panel? This is actually a picture of Hans's house. The very first CLT structure I ever went into, I was almost offended in 2003. I could not believe so much wood. And here I was, a wood guy from the very get-go. We had a machinery, and I was just like, this is insane. But the more I looked at it, the more we got into it, the more we saw how it worked and how it performed, the more we started to fall in love with it. And the more customers we started to get to know. This particular panel is an NLT, like Lucas was talking about. And it's a full line that's produced by Hundegger. It's called MHM, the Massive Holzmauer machine, that will actually take these boards. And can you see those little grooves in that? It actually plows in these air gaps, which are thermal breaks. A little bit different than glue up. They're intentional air cavities to add to the insulation and the performance. And they'll actually calculate thicknesses based on the climate and how the temperatures will then go through these walls. This particular home that Hans built was built out of this NLT type of a product, and he went to work and developed a full machine that does both a nail lamb floor and roof panel and also the wall panels in this graphic. The reason it really caught on, it was really kind of funny to me, but when Hans first was excited about his house, he asked me to make a phone call with my cell phone. And of all the benefits, one of the things that he thought was most attractive was that he couldn't get cell phone reception from inside his home. And it's a different culture, it's a different mentality, and I can talk to Laurent about this for days, but they really are health conscious, and they're very conscientious about natural and clean filtered air, not mechanically filtered air or being brought in through mechanical operation to do air exchanges. It's a very healthy thing. And so as they go through the benefits of selling this MHM system, they have the same types of benefits that CLT does, but they go a little bit further. And there's a lot of help we need in taking some of the studies that they've done over there, the science that they've used over there to show insulative energy code type things that are very important over here, that are hard to accept over here for some of the inspectors. We can go through structural, we can go through fire, but some of the energy code things, they look at things over there on the U value, where we look at things on the R value. And performance of this wood, there's a whole metrics of placeholders and different parts of the wall that work together as a system that perform completely different from what just an R value is. And they have found that these walls that are in the 10 to 11 inches thick are performing. They aren't rated at this, but they're performing as if it were an R50 because of the thermal mass, the performance, and going through. Just a simple 10-inch solid wood wall performing at an R50 from the University of Graz in Austria. They also have found huge benefits with the cleaner air. They don't vapor wrap this stuff. They have a rain screen. They use natural insulations like hemp and wool, but it's a purist type of a wall system, very similar to what Lucas was talking about with the pure nail lamb and just a little bit less sophisticated. So that's the massive Holzmauer, part of one of the Hundegger lines. This is actually a demonstration video of the line. Again, they take what would be considered scrap a lot of times. It's 1x-pallet type material, number 3. They run it through a special molder that cuts in that tooth dental type of air gap, and then they take it over to another machine that lines it up in the X direction and the Y direction, and then it's an aluminum nail that carbide tooth skill saws or radial circular saws and chainsaws can cut through. So they line it up and just simply nail it back and forth, and they can there's no cure time or line time. I mean, as soon as they're done building it up to the thickness that they need, they move it on down the line to what we call the PBA machine. This is the machine I talked about earlier that was being used for SIPs. It goes into this machine, and there's laser lights that will kind of square this thing up, and you'll get exacting tolerances. They can square it up so that it's perfectly 90 all the way around, cuts it, and then it will mill out an edge for a plate attachment or some kind of detail, whatever's necessary to attach it to the foundation or to the plate. That's the skill saw that can go from 90 to 0 degrees. This is the chainsaw again being used to cut an opening. It's a special tapered chainsaw that will go in and come back out without any radius. It's a very clean corner, specifically designed to cut through 10, 12, 13 inches of solid wood. The servo motors and drives that operate this thing, it's completely talking to itself every time it moves, so it knows exactly where it's at. Very little, it's almost calibrating it as it works. This is a wire chase, electrical wire chase to an outlet, European style. But they'll just chase the electric up that into the outlet hole, and then they'll cover it with a different material or a facing material as they end it. The Hundegger office building, brand new building, Hundegger believes so much in this. They just built their new office, sales office and operations is done out of this building. It's actually designed in the shape of a sawtooth, of a saw with the teeth. I'm fascinated with this building and what they've done because it shows the flexibility of what CLT can be or NLT can be with the right technology and some forethought and some design, and going all the way through the whole system from A to Z, looking at the details of connections. But each one of these walls is offset, so it looks from above, it looks just like a circular saw blade. We've also seen our saw used with a couple other manufacturers over in Europe. They're doing some very interesting fabrication of panels of mass timber, and I wanted to talk, we've talked a little bit about NLT, and Lucas did a great job with that. I feel like I'm stepping on his toes a little bit, but this is what they call Dow laminated timber. And this is a company in Germany called Inholz, and they have an interesting way. I think you'll see it pretty quickly here, but they drill and dowel at the same time. It's a one-man operation. They dowel these timbers together and finish them and ready to kind of stitch them together into larger panels. And then those panels are sent to a PBA type machine, a CNC machine that will then cut router and arches and different angles or bevels for gable ends. The other form of panel, mass timber panel, that I wanted to talk about, did I skip something here? Yeah, sorry. Is this is what we call ICLT. It's an interlocking cross-laminated timber where joinery is used. I think Ben was here earlier this morning talking about University of Utah. This is a Euclid product that we've been working on since 2005 or so, when we finally caught on to this great idea of mass timber. We've been working with the engineering department at BYU, the architectural department at the University of Utah. the U.S. Forest Service and the University of Idaho on putting together a non-glued mass timber panel that has the air gaps and provides the insulation and performance of those high-performing walls of Europe. And we're making this in two-foot increments and up to 26 feet long. We've used this with our timber frames as trusses and columns and beams. We've put the roofs on and the walls in some very unique and great structures. We worked with the University of Utah on the Girl Scouts project. This is a steel-clad building and zero insulation, just the rain screen of the steel on the outside and the timbers on the inside, or the mass timber panels on the inside. This is a home we did up in a place called Wolf Creek. It's all our ICLT walls and a dowel laminated roof panel with our timbers throughout for the internal structure. And we even used some actual round logs. It was a nice mixture of what's going on in there. I just wanted to show you a quick study from the University of Graz that was very interesting to me. They took some cube-type office-size buildings. One was a stick frame 2x6 with cellulose insulation. The other was a insulated concrete masonry panel, ICB, and then a ICLT wall. And what they did was they brought each room up inside, they heated it up to 70 degrees, and they put them all in a large room about this size and brought that down to 14 degrees. And then they turned off the power and the heating source to each one of the three cubes and timed how long it would take to get each room down to freezing. And down below there are the hours. The stick frame building with cellulose was 25 hours. The insulated concrete masonry building was 75 hours, and the solid wood ICLT building was 225 hours. So we can't really say that some of these products are the same as a CLT, the glued lam, because I think they get a higher rating in shear and stress. We're working with Utah State on this project right here, where the DFCM, the Department of Facilities Management and Construction in Utah, had no problem buying off on the structural loads and no problem buying off on the fire codes and what we needed to meet for that. What they are having a problem with is the energy code. There's a very stringent statewide energy code on state buildings. And we're really struggling with how to explain to them that you can't just look at this as a solid piece of wood. With the engineered gaps and the air gaps and the different rain strings and how the radiant heat works with the timber, it's a long process, but this is going to be a fantastic building. We got the award to move forward with the grant, with the Wood Innovations grant last year. We're just about ready to have construction drawings. They've raised the funds where we're actually going to build this building. And it's an organic botanical garden where they are going to do extended education showing how to prepare organic foods and really use organic building materials that are just natural ICLT type of a product. So anybody out there interested in, I've talked to Sue and a couple out there that are interested in working on the thermal dynamics of panels such as these. So again, I appreciate you letting us present to you. I hope you found some interest in what I've said and what Lucas said, and hopefully in Laurent. But again, the whole is greater than the part. All of us working together. There's plenty of room. There's plenty of opportunity. I think as a group, this is fantastic because we are stronger as a whole than we are as just our individual little parts. And I appreciate you being here. Thank you.